Hello friends, good morning all of you. Here I am Gadekar Sachin Pandit. Today we are going to learn about terpenoids. Terpenoids in which citral molecule. Okay. So last lecture yesterday we are discuss a classification of terpenoid. This classification depends on isoprene unit. Okay, sorry, isoprene unit. Okay, if present in isoprene unit 1, then its class is hemiterpenoid. If two isoprene units are present, to forms a monoterpenoid. Okay, and this monoterpenoid is known as a citral. These citral or citral terpenoids are present in example citral, limonene, alpha terpenol, menthol, dipentanone, alpha pinene, camphor. Okay, so this is the present a citral types of terpenoids or monoterpenoids presents two isoprene unit. Okay, so then monoterpenoids are classified into three classes such as acyclic, monocyclic and bicyclic. Okay, then we are also discuss a isoprene rule. Okay, so isoprene rule, this isoprene unit C5H8 or 2-methyl 1,3 butadiene. Okay, so head and tail combines to forms a polymeric chain, and this is nothing but a terpenoids. Okay, so then we are also discuss a general methods for structure determination of terpenoids. Okay, then we use a molecular formula for structure determination, detection of unsaturation by using UV and addition compound, then nature of oxygen functional group. Okay, then acid, then carbonyl group, oxo group, etc. Then degradation process, oxidation process, ozone process to determine the structure of terpenoids. Okay, so today we are discuss terpenoid in citral molecule. Okay, so citral, its class citral belongs to acyclic or open chain monoterpenoids, and its occurrence citral occurs in lemon grass oil. Okay, there are 70 to 80% lemon oils in lemon grass oil. Okay, so isolation, it is obtained from the lemon grass oil in the form of sodium bisulfate, which on hydrolysis to gives a citral, and this is the structure of citral. Properties, it is a colorless oil and its boiling point near about 228 degrees centigrade. Okay, so it is optically inactive, means achiral. There are no chiral center. Okay, so uses of citral, it's mostly used in perfume, cosmetic industry, also beauty soap, etc. So here physical property of physical methods to determine structure determination of terpenoids. We use for structure determination such as different techniques are used. Okay, UV spectroscopy, IR spectroscopy, NMR spectroscopy, mass spectroscopy. These techniques to use for structure determination. UV spectroscopy used for the detection of conjugate in terpenoids. Okay, suppose IR spectroscopy. IR spectroscopy, these techniques used for detecting the presence of hydroxy groups and oxo group. Okay, so also distinguish between the cis and trans isomer in presence of terpenoid. Also use IR technique used for qualitative measurement to determine the number of methyl groups present in this class. Next is the NMR technique. NMR technique we use for the structure determination such as hydrogen environment in the molecule. Next is the mass spectroscopy. Mass spectroscopy technique used for determine molecular weight or find the molecular weight by mass spectrometry. Okay, so these four techniques used for structure determination of terpenoids. Next is the synthetic method. Okay, final structure is confirmed by its synthetic status. Okay, known as compound in the laboratory. Okay, so now structure elucidation of citral, structure determination of citral molecule. Okay, so there are different methods. First, constitution of citral molecule use molecular formula. What is the molecular formula of citral? C10H16O. This is the molecular formula of citral. Second, presence of two double bond in citral molecule. Okay, citral is treated with bromine or hydrogen in presence of platinum metal. It forms citral tetrabromide, means 2 moles of Br2 bromine molecules used in citral molecule, that is presence of two double bond. Okay, so we use ABr2 2 moles of bromine, it means that presence 2 double bond. Also we use H2 hydrogen. Okay, there are 2 moles of hydrogen H2 to use for reduction. It means that citral molecule contains 2 double bond. Second method, citral as an acyclic compound. Formation of above products shows the citral is a acyclic compound containing 2 double bonds. Next is the nature of oxygen atoms present in citral molecule. Okay, nature of oxygen atom. Okay, so citral molecule presence of aldehyde group. Okay, the formation of oxime with hydroxyamine indicates that presence of oxo group in citral molecule. Okay, second, citral on reduction with sodium mercury gives a alcohol called zeranol. Okay, suppose it's sodium mercury reduction of carbonyl group to form a hydroxy group and form a zeranol. On oxidation with silver oxide to yield a zeranic acid, COOH group, means aldehydic group converts COOH. Okay, so acids say some number of carbon atoms and citral. Okay, so nature of oxygen, it's indicate that oxo group in citral is an aldehydic group. Okay, so here a reaction. Okay, C10H16O, it is a citral molecular formula, and this reacts with NaOH, NaHG reduction to forms zeranol. If we use a silver oxide to form say zeranic acid. Second, position of aldehydic group. Okay, so we use a UV spectrum in citral shows lambda max at 230 nanometers. This absorption indicates conjugated aldehydic groups. Okay, so another, on hydrolysis with aqueous potassium carbonate gives 6 methyl 5 heptene 2-one, means cyclization takes place. Sorry. These citral molecule on hydrolysis with potassium carbonate to gives a 6 methyl 5 heptene 2-one and citral aldehyde by breaking alpha beta double bonds. Okay, suppose this is the citral molecules reacts with sodium carbonate to forms a 6 methyl 5 heptene 2-one and acetaldehyde. Then hydrolysis to gives a ketonic group and acetaldehyde. Next is the carbon skeleton in citral molecule. Okay, so this carbon skeleton citral is heated with potassium hydrogen sulfate. Potassium hydrogen sulfate KHSO4 heat, okay, to forms a paraxylene. Okay, what is the difference between cymene and paraxylene? Okay, so in this 1,4-dimethyl are present in paraxylene, but here this 1-methyl group substituted by dimethyl. Okay, so citral reacts with potassium hydrogen sulfate KHSO4 heat to form a paraxylene cymene. Okay, sorry. Next is the oxidation of citral molecule in presence of KNO4 or CrO3 chromium oxide to form a acetone and linoleic acid and oxalic acid. Linoleic acid, it means that presence a double bond, okay, terminal double bond. So citral undergo oxidation with KMNO4 followed by CrO3 yield acetone, oxalic acid and linoleic acid. So another method, ozonolysis. Okay, so citral ozonolize to give a acetone and levyl aldehyde and glyoxal. Conformation analysis of citral by Barbier-Boholt synthesis. Okay, so in first step we use a 1,4-dibromo 2-methyl butane. Okay, 1,4-dibromo 2-methyl butane reacts with soda acetyl acetone. Condensation reaction takes place and then hydrolysis to give a methyl heptanone. Okay, in second method this converts to geranol here, methyl heptanone. So this oxidative degradation representation of citral. Okay, suppose citral we use a sodium mercury and dilute HCl to form a geranol, means aldehydic group converts to alcoholic. If citral oxidize in presence of sodium mercuric oxide, silver oxide to form a geranic acid. Okay, so ozonolysis to form a oxal plus linolenaldehyde. If we use a oxidation plus chromium oxide to form a linoleic acid. Okay, so this is the representation of oxidative degradation of citral. Next, conformation synthesis of citral. First, Barbier and Boholt reaction. Okay, 2,4-dibromo 2-methyl butane reacts with sodium acetyl acetone to form a condensation takes place, and then hydrolysis NaOH to form a methyl heptanone. Another method, methyl heptanone into citral, conversion of methyl heptanone into citral. Okay, so this reaction, Barbier reaction. Okay, so this methyl heptanone reacts with alpha iodo ester in presence of zinc, that is Rifer-Masky reaction, to form a salt, and then hydrolysis to give a 2-hydroxy compound. Then this we use a acid anhydride, and then hydrolysis lime to give a calcium adduct, and this distill to form a zeranol or citral. Okay, so this is the method for preparation of citral by using Barbier reaction followed by Rifer-Masky reaction, then hydrolysis to give a citral. So thank you for watching this video. Have a nice day. If any queries, then comment below. Thank you. Have a nice day.